Are you laughing at me, Buyo? I think you're laughing at
I'm
me.
so sorry. Oh my gosh. I am with my amazing
I don't think I'm putting off the cyberpunk very well. I look like a fly
you,
or
you
something.
can't even see my face. It's crazy. Yeah. So hi, Seb. You are my wonderful co-host for the rest of the day. I am excited. Are you excited?
I am excited. I've been watching some of the previous talks online. It's
What do you
looking
mean
really
some of
good.
them? You should have been watching all of them. What is this, huh? So
Now you have
yeah,
to
no.
sleep.
Yeah, so I just want to give people a brief reminder of the code of conduct that this is a harassment-free space. We want everyone to feel comfortable. We do swear a lot. You won't hear it from this side, but then we do swear a bit. But yeah, so if you've got any for the speakers that are giving us wonderful talks for today, please post them on Brillo. We're looking forward to reading them and interacting with the speakers some more. Seb, my wonderful co-host. Huh? I like your glasses.
I hope you like them because I don't see them. I can't see pretty much anything.
You can't even see your co-host, but it's all good. Yeah, so I think we'll give it away to Yshay, a CTO at
Yshay.
Lifecycle.
Yshay.
Yeah.
Isha, oh,
Shy.
shy.
That's okay.
Sorry about that. Yes, Yshay. We're going to give it away to Yshay. He's going to be talking about instant self-contained development environments for everyone. So I'm really looking forward to that talk, and I hope we learn a thing or two.
Take it
Thank
away,
you.
Yshay.
Thank you very much. I'm super excited to be here. So I'm Yshay. I'm the CTO of Lifecycle, CTO and co-founder. And today I'm going to talk about self-contained development environment for everyone. And to give this talk the right scope, I want to share a story I had like a few years ago. I led a development team that built like an open source solution for a feature of flag management. And it was like internal company product, but it was developed like in open source, and it was like on a public repository. And we want contributors from coders for the company to contribute code to the project. So the project was called Tweak, and we thought to organize an hackathon for that. So we called this hackathon a Tweakathon. And it was a really exciting time. We got like lots of swag and t-shirts, and we had like lots of documentation and backlog with dedicated items. And at the end, well, it didn't work that well, to put it gently. The problem was that most developers were struggling to get the application running properly, to build, to run. I mean, they didn't even some of them didn't get even to the part of developing new features or fixing bugs because the onboarding was so difficult. And my team was actually going from desk to desk and helping developers run the project, but it wasn't working that smoothly. And today I'm going to talk about how we can create an amazing onboarding experience to developers when they are starting to work on repository or on complex project. Before we start with that, I'll introduce myself a bit. I'm Yshay, I'm the CTO of Lifecycle. I'm a full stack developer. I'm passionate about cloud development, backend architecture, Docker, functional programming, and lots of stuff in buzzwords. I'm also the creator and maintainer of Tweak, an open source cloud native feature management solution. And I really love like simplicity and consistency and elegance in code. Few words about Lifecycle. So we are building the next generation of collaboration tools for development teams. We're all about like bridging the gap between coders and non-coders, and we'll be soon in public beta. So you are more than welcome to check it out. Okay, so let's try to scope the problem. So how does it feel as a developer to start working on a new complex code base? So the first thing, we are going to try and build and run it, but we might don't have the right operation system because the project was maybe developed and optimized for Mac flows, and we are working on Windows or Linux. Additionally, we might have missing or conflicting SDKs or programming language runtimes, the right or wrong version of Node or Ruby or Python or something. And for Node developers, you probably know this feeling when the package manager throw random errors at you and you're not sure what's going on. So that's the first thing we need to walk away from. Afterwards, the project is running, but it doesn't work properly. So we probably missed something in the README. Maybe we need to run some magic script, change the host file in many cases, maybe install some database or other dependencies that the environment needs. And if your project is really terrible, you might need to do something very intrusive like install a root CA, but I hope you don't have this case. And okay, we build it and run it and everything work, but which we wanted to develop, not just building and running it, right? But debugging cannot work properly. The IDE may have problem with autocomplete or dependencies. We have a problem maybe with watch, and maybe the auth model reloading if we are doing front-end stuff doesn't work, and lots of problems. And even after we managed to run on all that, we have integration tests that usually just fail the first time you are going to run them, especially if they're Selenium or stuff like that. And the worst thing about it is that we probably will do it all over and over again in a few months, whether maybe because we moved to a different station, or maybe the project got updated with dependencies or other tools. So why this process is so difficult? And I think that one of the main reasons for that is we have like lots of fragmentations of SDK and runtimes and developer tools. We tend to have like this work on my machine syndrome. So if it works on my machine, I'm not going to touch it. I'm just going to run it. And I'm not going to think about how I'm going to make it work for the next time I'm going to like try to run the application on a different machine. We have so many tools, and especially now when we're working with microservices or other more complex environment, it got much more difficult. And at the end, we are going to waste lots of time, and it's not just time, it's also frustration. Not to mention, we are polluting our developer machines with lots of tools. So it's like developer machine is terrible in that area. So how can we make it better? So the way I see the dream is like we have development environments that are consistent. They provide like the same predictable experiments for everyone. They are reproducible. We can destroy them, rebuild them, whatever. They are isolated. So if we are running several environments in parallel, they are not affecting each other. So I can have like different version of Python, or Node, or PHP, or several databases that are running. And most importantly, they are self-contained. So all the dependencies and tools that need for the development are defined and packaged inside this development environment. And these properties probably might sound familiar to you, because there's some of the properties we use when we describing Docker containers. So we have like the idea of a container that is reproducible, self-contained, can run everywhere, portable. And the thing is that 2 years ago, VS Code, one of the most popular IDEs, had support for developing software inside a remote container. So the idea is pretty cool. In terms of, it's not like a full remote access solution, because the IDE is run locally. We have like the full user experience of running locally, but the backend of the IDE, of the backend of VS Code, is running inside a container. And in the backend, we have like the file system, the file itself, the extensions, and all the relevant dependencies. And we can create the backend with a container. So in this talk, I'm going to show some examples on how we are going to use developer containers on different projects with different level of complexity. All the tools that I'm showing here are open source and free to use, so you can use it on your own solutions. And because I'm going to show like several examples, I hope everything will work well. So let's start. The first example I'm going to show is actually pretty simple. It's a CLI tool for creating ASCII art from images. The thing is, it's written in Go, and it's written like in Node version of Go, before we have Go models. So it's an open source solution. We can see it here, the GitHub repository. And we give it like a file, and we're going to get like an ASCII out of that file. So I'm going to show my VS Code that is configured to run this project. And the thing is that you can see that it's running here inside a dev container. Now, what does it mean? So to illustrate that, I'll open here a terminal, and that terminal is running on my computer. And if I'm going to run here Go, you see that Go not found, or dep, or other tool that use in this project. But here I have them. I have like Go, dep, and everything, because although this terminal feel like very natural, it's not actually running on my computer. The IDE is running, but the terminal itself, I'm connecting to a remote container. Okay, so how does this magic is happening? We have a dev container JSON configuration. Here we can define the extensions we want the IDE to use. So here I have like the Go extension because I'm going to develop in Go. I have several settings for that extension. And I have like the Docker file that define what I'm going to put inside this container. So here I have like a Go version 1.6. Because this is an old version, I'm turning off a Go models because the project is, as I mentioned, is a bit old. It's using like a different mode for dealing with dependencies. I'm also configuring my shell. I'm installing the dependency manager. And in the shell, I'm also running like plugin for Git and Golang. So I have like nice experience. And everyone will get like the same experience. In addition, you can see that the project is running like in a special folder for Go, because in the past we needed to actually clone repositories in random from a specific folder. So again, the users themselves that are opening the repository don't need to deal with that because everything is defined in the dev container. So let's try to run the application. I'm going to do like Go run. And we see that it's working. I'm going to put like an image. I think I got it here. Okay, and I try to write like a remote image. The library doesn't support it. And I want to add like this feature. So I can see that if I'm going to try to hover on some of the properties there, I get like a good experience. Everything work out of the box because everything like defined like to be in the right folder, the right version, and I just opened the repository. And the cool thing here to add the support of like running a file PNG from like a remote server, I need to change it. Because we are doing it live and I don't have that much time, I'm going to just move to a branch that I already implemented. And the change is quite, there isn't like lots of code here. I add support for like doing like HTTP, and I'm running it again. And we see that we got an image of Docker running in that case, and it could be like other image as well. Okay, so that's working, and I can try to run the test. It doesn't work because I didn't run the dependency tool. So I'm going to do like dep ensure. And then I'm going to run the test and everything works. And all the tools and all the settings are inside the container. So that can save like countless hours in a more complex project. And even in side projects that you have like lots of legacy stuff, you need to figure out how to make it run and work. So let's recap what we saw in this example. We saw that we have a development container. We saw that we have like remote terminal, remote code editing, the integration with the SCM. So I was able to do like checkout. I can also do like directly commit, push, and everything. We saw that we can configure the environment, like setting runtime SDK, CLI, environment variable, configure our shell, define the extension, like the Golang extension. So that's awesome. Let's take it a bit more. Let's try to look at a more complex example. So here I have like a Python server, it's a Flask app, and I need to run and interact with the server. The server is running inside a container, so I need to do some magic on how to connect it with my localhost. I also, because it's based on SendGrid, I need to have secret, and I want to show how we can make them self-contained, and I'll show debugging as well. So that's the code. It's based on the SendGrid app example. And that's the development container for that. So let's look at what we have here. We have like a Docker file, some setting on Python, the extension we need for Python. And here we have like the port forwarding 5000, which means that the port 5000 inside the container is going to be forwarded on my local host. So every time I request hit my local host, it's going to hit the container as well. So that will be used when we are trying to run the server. In addition, we have here the Docker file of Python, and beside Python, we are installing another tool called SOPs. SOPs is a tool for Mozilla that deals with encrypting secrets. And the idea here that I have this JSON file that contains my SendGrid API key and also my email when I'm sending, but everything is encrypted. So no one can use it, and it can be safely be put in the repository. And to showcase how we can use it, I created an additional file that called example that contains some number, which is not really a secret. And I can show that using SOPs, we can decrypt this file. So we see that the number here is 100. I can also edit it. And the moment I'm going to edit it, the encrypted file is going to change as well. So that's how we can have secrets that are also self-contained. And currently I'm using a key that is based on GPG, a key, but it can be much more sophisticated, and I'll touch it later. So when I'm running the application, I'm going to take the secret anchor of the Python app and create a .env file. So it's very, very simple. And the .env file is not in the source control. Let's try to run the application. So we have like this Python app running, and I have here, So I have here like a test message. We can see that the application here is running, and I have, I can try to test an email. I'm using Melanator, and we see that I just got this email. So it simply works. And in addition, it's not just about, the reason I can run like the Python app like in one command is because I configured the launch JSON when I'm going to run the application. So developers don't need to deal with that when they are opening the repository. And in addition, it's not just running, it's also debugging. So you can see that if I'm running it again, I'll get like the experience of a breakpoint, and everything simply works. So let's go back to it. So in this example, I show, first of all, that we can use secrets and put them in the repository if we encrypt them, and making the experience still more, have like the experience of a self-contained environment that defines the repository. This practice of secret encryption is also used in GitOps context. So Gitseeker, Gitcrypt, there are other solutions, not just SOPs. And the cool thing about it is that it doesn't have to work with GPG keys. It can also work with a cloud encryption as a service solution, such as KMS and Key Vault. So it can be done in a very secure way. The metadata itself is not encrypted, like the name of the keys. So it can also be easy to do like diffing and check history. So it's really nice. And also I show that like in the IDE, I can look at the launch JSON to configure how the Python app is going to run, and do like the port forwarding stuff as well. The next one I'm going to show is a bit more big project that's quick, the one I mentioned in the start of this presentation. And here I have like lots of challenges. We have several microservices, database, many programming languages, cross-service communication. Basically, the architecture of this project is something like very complex and difficult. And that's one of the reasons why it was so difficult to run for developers. And then I'm going to show that I have a development container as well for Twig. That was the project. I have a Docker file that inside I have a nested Docker container. So basically, Twig has its own Docker daemon that we can use to run the other microservices. We have all the other tools that we need. We have .NET, Go, and Node. And the thing is, once we have like a Docker that's running inside, like Docker in Docker, we can run the application, and I'm running the application using Tilt. It's basically a tool to run the Docker compose definition that define all the other microservices that are running. But the nice thing about Tilt is that it's going to do like auto loading if a file is changing, and like do automatic build. So it's like Docker compose with Watch and with the ability to copy files. So just to showcase this example, I'm going to go to the UI of Tweak, and that's, for example, our login page. And I'm going to change here, welcome. And let's say we are going to do like big font. And if everything works properly, we are going to show it change live, and we have like superb developer experience. Everything is just working. And I can say that like in the past, this thing were not, it was like nightmare to work on such a complex project. So that's, it will see like a complex architecture working. We see that we are running Docker inside of Docker with Tilt. It can be costing some performance, but it's still running very well. And it provides the way that also this developer environment is totally reproducible. So everyone can start easy, and if they do some damage to this environment, they can just rebuild it. So it's very, very powerful. In addition, when we are running locally and we're running like a self-contained project, one of the things we can do is like mock some of the dependencies we have. For database, we can use the Docker image of them. For cloud services that provide like OpenID Connect services like Google or Microsoft, or for object storage like S3, we can use Minio. And for the OpenID Connect, we can use like a mock server. So that allows us to run like this project locally and in a very efficient way. And the last one, because we are in a cloud native conference, it's also possible to run a Kubernetes project inside a dev container. We have several challenges. We need to run Kubernetes, metric server, and Prometheus. Cost model is a project to manage and see the cost of your Kubernetes cluster. It's an open source project. And the thing is that Kubernetes local development is already difficult. We have like lots of distribution of Kubernetes. We have like this fragmentation, versioning, upgrading, very difficult. And the idea is that if we use a single Kubernetes distro version, it can make our life easier. So that's my last example here. So that's the project of cost model. So it's already running. And the idea is that we have the same dev container with extension of Kubernetes. But the interesting part is that in the Docker file, we are not just installing Docker in Docker, we install kubectl, Elm, and other tools related to Kubernetes, and we install K3D, which is a solution to run Kubernetes inside Docker, and a specific distribution of Kubernetes that is very lightweight, that is possible to run in like less than 30 seconds. And afterwards, we are going to use the same tool I used in this previous example, Tilt, and I'm going to run the application. It's already running here with Tilt up. And you can see that I have like the application here running. And again, it's application that is very complex. It has like Kubernetes, Prometheus, and lots of moving parts. And again, we can run it like open the repository and run. Another thing that is interesting here that we are also using Elm. So we have like a manifest that defined the installation of Prometheus. Prometheus is like a time series database that we are using to collect, that the app is using to read all the relevant metrics. So that application is very complex. And I'll summarize here that we use Kubernetes inside a dev container, which is really weird. I mean, there's like lots of nesting here. And we have like a Tilt using the build and push and running flow. And again, it's stable. The dev environment can be torn down and recreated easily. And from how does it look? So to put it simply, we have like a Docker that contains our RDE, that contains Docker and Docker, that contains Kubernetes, that contains containerd, that contains our app, or visually it's something like that. So yeah, lots of nesting stuff is going on here. So no more demos, and I'm going to share that first of all, containerized development environment are very powerful because the environment configuration is also source controlled and it corresponds to the application code. So we can go back in time and run the application to work. The developer machines stay clean, so we don't install anything on our own host. It can scale well to multiple environments and it can run locally or remotely. So for example, some of the demos I shown here are running actually on a remote container that running on a remote machine, but it can also run on a local machine. It's not just a theoretical idea or tool. We actually use it for more than a year for our own development environment, which is very complex. Have like lots of microservices and Kubernetes controller and DB and CI and whatever, lots of things there. And even though this environment is complex, the time that it takes to build and download and rebuild all the cluster and dependencies is less than 15 minutes. To build, run, test code changes, it's less than 10 seconds because everything is configured like correctly. Time to onboard a new developer is less than 3 hours, and that includes the time of creating a dedicated host on AWS if they want to work remotely. There's no work on a machine syndrome. Developers don't need to deal with secrets because they are self-contained. And we don't have a strain on developer machines if we are running them remotely. So it works really well for us. And it can be further optimized with shared build cache and lots of stuff. But it does have some drawbacks. I mean, creating this setup can take some time initially because we're creating code that we need to manage. There are many tools here that can be involved. And because this is not a standard yet, dev environment, containerized environment, we do have coupling to VS Code, Docker, Git, and Linux at this point. The way we see it, we think that it's like part of a larger trend to put more stuff in the repository. So we can say like CI in the past, we didn't put like the configuration inside the repository and now it's there. The same goes like with design system and documentation and workflows and all like the practices that are related to GitHubs like infrastructure as code. And I think that in the future, we'll have like repositories that are completely like self-contained. Every code, tools, knowledge definition is reside inside the repository itself. Git is the single source of truth. The application are portable. The developer experience is very fine-grained, so the owners of a repository can create the right experience for each one of the developers that they are working on this project. And in addition, we'll see like emerging tools ecosystem, like cloud IDEs, dedicated PR environments, like one of the things we see in Lifecycle. And we can say it like with other projects that we saw like Gitpod or the GitHub code spaces and many other projects as well. This is like a cheat sheet of all the tools I mentioned here and what the challenges and what the solution and how we use them, because there are like lots of different tools here, and you can check it out in the repository of self-contained repository. And first of all, thank you very much. And again, these tools, you can use them yourself. It provides great experience. And I'm available for questions if we have time.
Thank you, Yshay. Thank you. That was great. I think this is the way that open source project should do it from now on. You know, like I want to go to GitHub and see a repo and be able to run it just right away, not go to all the README and have the thing that if I have I don't know, different versions, I need to, forget about the project or do something else. This is, you definitely have something. We are short on time. I don't know if we have any questions. We don't have time actually for questions, but thank you so much. If they do, they will appear on here umbrella, so you can stick around. Also on Twitter, people might use the hashtag to tag you. Thank you.
Thank you very
It's been
much.
great.
Thanks.